Hello students, today we are going to learn breadth first search algorithm. So as we know, in artificial intelligence there are two categories of searching algorithm, informed search and uninformed search. So this BFS comes under category of uninformed search. In uninformed search we are not having any kind of heuristic knowledge. First of all we will see how it works, what are the steps, and then we will see its example. So BFS starts from initial node, which is root node. Then we are expanding all neighboring nodes before moving deeper. Here we are using queue type of data structure to keep track of the nodes. The queue is FIFO type, which is first in first out type of data structure. And then we are continuing exploring all the nodes until we get goal node. So now we will see example. So see here we have a tree of node A, B, C, D, E and F. So here we want to perform a breadth first search. So how process is going on? Here the root node is A. So first of all we will take a queue where only one node is present, which is A. Then in next step we will perform a removal operation. So the first element which is going to remove is A. That means we are visiting A, and in the queue we will insert the adjacent nodes of visited node. That means here we have visited A, B and C are the adjacent node or neighboring node. So these two nodes will be inserted in the queue, B comma C. In next step again we will perform removal operation. So B will be removed. Now B's adjacent node will be inserted into the queue. So B's adjacent nodes are D and E. So now in queue we have C, D, E. Again removal operation perform, we will get C. That means we are visiting C node, and C's respective neighbors will be inserted in the queue. Now in list in queue we have D, E, and new element is inserted, which is F. Again we will perform removal operation. We will get D. So we will visit D, and inside queue we will insert neighbors of node D. So here in this example node D is not having any neighbor. So we will not insert anything in this. Next again perform removal operation. So E will be removed, visit E and insert E's neighbors into the queue. So E is also not having any neighbor. So nothing will be inserted. Again perform removal operation. So we will get the F node. So visit F node, which is the last element, and now we can observe that the queue is empty. That means the traversal process is finished now. Now if you check which nodes and which sequence we have visited, so we will get output like A, arrow B, arrow C, arrow D, arrow E to F. So this is the traversal. So in this way breadth first search will work. So basically in this case we are moving a level wise. Then what is the space and time complexity of this? So time complexity is O of V plus E, that is vertices plus edges, and space complexity is O of V, where V is nothing but the nodes, visited nodes. So in this way BFS works. Thank you.